Okay, so it says find the equations of the two lines parallel to the line 3x plus 4y minus 6 equals 0 and which are tangents to the circle. So I'm going to draw your circle. And this circle we know has centre of 0, 0 and has radius of root 25, which is 5. Now what it's telling us is we have this line coming through here. We don't know where it goes through, but say it's there. And the equation of that line is 3x plus 4y minus 6 equals 0. And there's two lines, it tells us, that are parallel to that and that are tangents to the circle. So that's probably here and here. Now we know these lines, if lines are parallel, the majority of their equation is the same, but it's just the last bit that is different. So these lines will be 3x plus 4y and then plus k equals 0. And the same for the other one will be 3x plus 4y plus k equals 0. And the only thing we know is from the centre of the circle to each of these lines, the distance is going to be 5, so it's going to be equal to the radius. So if I use my perpendicular distance formula, so I don't know what k is, but I know that my centre is my x1, y1, and I know that A is 3, B is 4, and C is just k. And I know that the perpendicular distance is equal to 5, because I know that if these are tangents, then the distance from the point to the line is actually equal to the radius. And this is my perpendicular distance formula. So I'm going to sub this in. So I get 3 times 0 plus 4 times 0 and then just plus k. And that's all over root 3 squared plus 4 squared. And I know that that's equal to 5 because I know the distance from the centre of the circle to these lines is 5 because they're tangents. So on the top, I just get k. And on the bottom, I get root 25, which is just 5, and that's equal to 5. And what I'm going to do then, so that means that the easiest way to solve this one is, you could do your squaring, but it's quite straightforward, is I know that the modulus bars, that means that this whole fraction is either equal to positive 5 or the whole fraction is equal to negative 5. And then multiply across, so that must mean I can get rid of my modulus bars because I've accounted for the positive and the negative case. So remember, modulus takes the positive version. So I don't know if the k inside those modulus bars was positive or negative. So that whole fraction could have equaled positive 5 or it could have equaled negative 5. And then just multiply across by 5. So you get k is equal to 25. Or k is equal to 5 times minus 5, which is minus 25. So the equation of the tangents then are 3x plus 4y plus 25 equals 0. And the other one is 3x plus 4y minus 25 equals 0.